Okay, so this is all review. Intermediate algebra. So we're going to discuss exponential function. And you guys did some work with exponential functions, right? So the exponential functions is f of x is equal to a to the power x. X is as a power. So this is an exponential function where this a has to be, a is greater than 0, right? And then exponential function, if you look at the definition, a is greater than 0 and also a cannot be equal to 1. If a is equal to 1, what's happening is that any number, any 1 to any power is 1, right? So we can't find the values of the function because we get 1, 1, 1. So a is not equal to 1 and a can be any number greater than 0, and for x is any real number. X is any real number. So we discussed this last class meeting. So the basic one we did is f of x is equal to 2 to the power x, right? 2 to the power x. All we have to do is we come up with a table of ordered pair. So table of ordered pair, 2 is a whole 2. So we get some x values and this is f of x value. We know that. So pick some values for x. X equal to -2, x equal to -1, x equal to 0, x equal to 1, x equal to 2. Right? X equal to -2, what's happening here?
1/4.
What's the y value? 1/4. X equal to -1, what's the y value? 1/2. X equal to 0, what's the y value?
1.
1. X equal to 1, what's the y value?
2.
2. X equal to 2, what's the y value? 4, right? So the graph, we know the graph of this is going to be like, we have to mark at least 5 points, right? So mark at least 5 points, go from -2 points and +2 points and the 0. At least take that. So what do you get here? X equal to -2, what's the y value? 1/4. So here x equal to -1, y value 1/2. Here x equal to 0, y value 1. X equal to 1, y value 2, y value 2. X equal to 2, y value 4. So this is the graph, and so the graph of this is that, right? Okay? Very easy. We have done graph. This is a function. We have done so many different types of functions now, right? So this is a function that exponential, the basic one. This is the basic exponential function. So now I'm going to do the same thing. Another example, another exponential function. F of x is equal to x, 2 to the -x. Now this, whenever we have this, I can write this as 2 to the -1 times x. Can I do that? It's the same thing, right?
Yes.
So this is the same thing. I can write like this. What is this means? 1/2 to the, this means 1/2 to the power x. So now this one we can rewrite like this, or this is a reflection through y-axis when x is negative x. Okay, so you can consider like that, or you can do the table of ordered pairs here. What do you get here? What are the numbers we are going to pick? What numbers? Huh? Negative, yeah, negative 3, negative 2, negative 1, 0, 1, 2. When negative 2x is negative 2, what happened? We have to switch, right? X is negative 2, 1/2 to the power negative 2 will give you 2 over 1 to the positive 2 will give you 4, right? So x is negative 2 is 4, x is negative 1, 2, x is 0. Anything to the power 0 is 1, x is 1, 1/2, x is 2, 1/4. So now we know this is, so pick some numbers. X is 0, 1, x is 2, x is 2 what? X is 2, 1/4, x is 1, 1/2, x is negative 1, 2, x is negative 2, 4. So you see the graph going this way. So this is f of x is equal to what? 1/2 to the power x, or we can write this f of x is equal to 2 to the, right? This is f of x equal to 2 to the negative x, or f of x equal to 1/2 that, right? Now, what's the other one we have? So you can see the other one we have is this, like this. So this is this, the other one is, so this is f of x is equal to 2 to the x. See, this is symmetric with respect to y-axis, right? So you can use the transformation rule. So symmetric with respect, or you can do all the negative power x, you can convert to this and pick up your ordered pairs, create your ordered pairs, table of ordered pairs, have the 5 points. Okay, have the 5 points, label the 5 points. You guys, some of you guys were still doing graphs on the exam like this, like this. I have no idea. It's very frustrating to see, I'm sorry. You're doing it like this, it's not acceptable. Might as well don't do it. You don't get any partial credit. For this class, I need to put, you need to have 5 points labeled. You don't have to label the point like this, label it, but at least one strong dot. You need to have it. If you don't have that, I'm not going to give any credit for the final exam. 0. Because this is something you need to follow classroom instruction. Okay, guys?
Yeah.
So thank you. So please make sure that you do it right, 5 labels. I'm just saying this to you so you get it right. You know what it is. Okay? So now if you want something like this given, f of x is equal to 2 to the negative x plus 1. What do you do now? You know 2 to the negative x plus 1, you move this up 1. Or f of x equal to, so you're going to have not these graphs, you're going to have graphs like this. Use the transformation. Use the transformation to graph. Okay? So you're going to have f of x is equal to 2 to the negative x, 2 to the negative x, 2 to the negative x minus 2, something like this. What do you have to do now? Move, this is with the x, right? So this 2 to the negative x minus 2 like this, right? So now you need to move to the move to the right too. The same, take the same and move to the right. So you already know, we spend a lot of time for transformation. You already know all the rules of transformation. So whenever you see, all you have to do this is use the transformation rule. So I might have on the exam something like this, instead of 1, like 4 or 3, you know, or -2, you know what to do. Or something like this, or plus here, you know what to do. Okay guys? So that's all I have to tell you about exponential function. Okay? Now, you can also, if you know how to graph this, what is for an example number, let's take this as 3. F of x is equal to, I would say, 3 to the, I gave this for homework, 3 to the x. It's the same thing now, right? Right guys? What's the decreasing function of this? F of x is equal to, what's the decreasing function of this? 1/3. You need to put parentheses when you do this to the x. Or we can write this as f of x is equal to, or f of x is equal to what? 3 to the negative x. You know why is 3 to the negative x works like this, right? You know that. Okay. So that's all I have to say about this. Okay. Now, okay, so now the other thing is you're going to use transformation. So instead of this problem, I might have 3 to the negative x plus 8. You know exactly what to do. Okay? Any questions? Any questions? So this is like the first problem. This is, you guys have done this before class. This is review. This is review. So this is not new. It's like you have done fractions throughout your school year, and when you do review, we go through a little fast. But I still explain to you from the scratch. Starting with the definition, creating the table of ordered pair, doing the graphs, I explain it. Okay? Alright. So if you get 1 or 2 questions from this, you guys know what to do on the finals, right? Okay. You also know f of x is equal to, we also get e to the x. This is called, this is the exponential function base is e. You know the value of e is irrational number, right? It's like pi, right? So you say irrational number is, so you're going to use the calculator to estimate the value of e here, okay? But if you look at these problems here, it's going through, exponential functions are always going through certain points. What are the points? Let's take this is our 2 to the x, right? F of x is equal to 2 to the x, right? So it went through what? It's also always went through what?
0, 1.
0, 1. So exponential functions always go through 0, 1. Okay? So this is a is 2. What is this? Negative 1 and 1/2. Negative 1 and 1/2. And what is x is equal to 1, what is it?
2.
What's the value?
2.
Y is 2, right? So 1 and a. A is 2, see? This is a. So this is 1 and a. You see that? What is this point? 0 and 1. So whatever this a, x is going through, the graph is going through. If this is 3, the graph is going, you don't have to know that because you know how to create the ordered pair and do this, right? We did this like couple exams now, right? So you don't have, but it's good to know that exponential functions are going through these points. Okay, so what is this point in terms of A? Negative 1 and 1 half, which is negative 1 and 1 over A. A is 2, so this is negative 1 and 1 over A point. So these 3 points, negative 1 and 1 over A. 1 over A. All exponential functions are going through these 3 points. Are you following me? The basic exponential functions are going through these 3 points. So all we have to do is graph E, just get these 3 points and graph E. Now the other thing we have to know here is when x is a positive number, a positive x here, the graph is called is an increasing graph. Graph is increasing, right? This is exponentially increasing. We are going to do some word problem with exponential increase. There are a lot of real life problems with that models exponential functions. That the graph is exponentially what? Increasing. So this we are going to use lots of real life problems, and this one is what's happening to this one? Exponentially decreasing. When the x value goes up from one value from left to right, one high, y value is dropping down more than one, dropping down more. The next one dropping even way more. It's like when you take, like we have bacterial infection, you take antibiotics, and the antibiotic is killing bacteria exponentially. Okay? Bacteria also can grow exponentially. Population growing exponentially. Okay? And what else can grow exponentially? Anything that you guys familiar with?
Taxes. Taxes. Interest rates.
Interest rate, very good. It's certain interest problems. Like if you have money in the bank and your bank accounts are, your saving accounts are compounded. Have you heard of compound interest before? You guys have done problems with compound interest before. This is all intermediate algebra. Compound interest, so that's another one exponentially, what? Increasing. So very good. Yeah, interest rate, but when the interest is compounded. Okay? It's not the simple interest. Simple interest is not exponentially increasing. Okay? So we are going to work with so here the 2 graphs are what? One is increasing function, the other one is decreasing. So what are you expecting here? E to the x. Increasing or decreasing? E to the x is increasing or decreasing? Increasing. Very good, right? Because this is e to the x. X is positive here. So what are the numbers we have to have? This is 0, 1. What one? This one going to be?
1e.
1 and x is 1 and e, right? What is this one going to be? Negative 1 and 1 over e. So you can estimate these points, right, using the calculator, and you don't have to put the real value, just write like this, that's good enough. You just put the e, okay? You don't have to put 1 over the value of e. Okay, if I give this one, you only put these 3, that's good. Because you know all the exponential graphs are going through this point. Okay, now if I say f of x is equal to this, because x to the e to the negative x, do we know how to graph this?
Yes.
Do we know how to graph this?
Yes.
What do you need to do? We did a similar one like this with 2. This is e to the negative x. Okay? Questions? Okay. So guys, so that's exponential. So all you're going to get is for on the test, something like this, something with the e to the negative x minus 2 plus 1 use the simple transformation to the given basic function. Okay? Questions? Okay. Okay guys, so you follow this. We have discussed so many exponential rules, about 10 exponential rules, the basic ones, right? So one of the exponential rules, I'm not going to go through the basic algebra. You guys already know, I don't have time for all that. So the basic ones we are not going to do, you know that. I'll send you, I'll give you a handout with, you can also look at this. It's some things like, x to the power 0, what is this equal to 1? X to the power n times x to the power n, x to the power n plus n. These are the rules I'm talking about, the basic rules. X to the power n times to the power n, x to the power mn, right? So you already know these basic rules. Know about the basic rules. Basic rules. Okay, so we know this, and then I want you, this is on page, so 408. So I'm doing it little differently because this is review. I'm not exactly following the book order. So what we did was so far exponential graphing for 5.1, okay? But this rule is in 5.4, I'll just write the page 408. It says a to the x is equal to a to the y. If you have an equation like this, a to the x is equal to a to the y, if this is the case, if this is true, then x is equal to y. We are going to use this. This is a rule. This is a new exponential. We have two functions, exponential functions that are equal. Then this means the powers are the same. Okay? So this is a basic rule. Two exponential functions that are equal, then the powers are the same. So using this now we are going to solve exponential equations. We are going to solve some exponential equation. So then we are going to go into logarithmic equations. Before I go into logarithmic functions, I want you to see how to solve some exponential equation. So exponential equations are on page, exponential and logarithm, they have this together. I'm only going to have exponential equations, 5.4. Okay, this is 5.4. Chapter 5.4. So basically what I'm going to do here is, I'm just going to go through some examples here, right? So example number 13, 5.4, 4 to the power x is equal to 16. This is an exponential equation. So we are going to manipulate this. You guys have solved this before. If we can convert this to something to look like the rule, then we know how to solve this, right? So how are we going to convert? So the bases are the same. The rule says the base is the same. If the base is the same, we know we can say x equal to whatever the power here. So how do you convert 16 into 4 to the power something?
4 squared.
4 square. So now all you have to do is the rule, use the rule. So here x is equal to 2. That's it. Very easy. Okay. Now let's do 1/4 to the power number 16. Number 16. 1/4 to the power x. 1/4 to the power x is equal to 64. How will you do this? How will you do this?
We do 1/4 to the...
We know this side is 1/4. We need to write this in terms of 1/4 to the power. Right?
So you would do 1/4 to the power.
So we are going to write this as what? 4 to the negative 3. What is 4 times? We know we can write this as what? 4 to the power? 4 times is 16. 16 times 4 is 64. 4 to the power 3. Okay, 4 to the power 3. But we want 4 to the power 3, this to be 1/4. Pardon?
1/4 to the number.
So if we write this as 4 to the power 3, can we write as 1/4 to the negative 3? Let's see what this is going to be. This means we need to switch, right? How will you convert this into positive 3? Positive 3 power. This is another rule we do this, basic rule. If you have x over y to the power negative n, this is a basic rule, guys. This is the same as y over x to the positive n. This is one of the basic rules you guys were supposed to be very familiar with. So now you write this down as another rule. I did write about 5 of them. This is in beginning algebra. Okay? So this is a basic rule that we are going to use. So you're going to manipulate this 64 to look like 1/4 power. So if I convert to 1/4 to the negative 3, how can I rewrite this? How can I rewrite this? 4 over 1 to the what?
3.
Positive 3, which is going to be what? 64. So 64 can be written like this, correct? Do you see that? So we just manipulate to look like what we want. Remember, we discussed this in mathematics, we manipulate stuff a lot. Okay? So we want to get this 1/4, because if you can get this power as 1/4 to the something, then we can use our rule. That's the reason we are manipulating. So now we are going to write this negative 3, this is 1/4 to the power x. So what's the answer to this now? X equal to negative 3. Everybody follow this?
Yes.
Everybody follow this? Okay. So you can work with this something when you get it. On the side, work it whether you can manipulate and get the same answer. Okay? Okay, so that's number 16. Now we are going to number 29. So number 29, e to the x is equal to e to the x squared minus 2. E to the x is equal to e to the x squared minus 2. Can we use the rule?
Yes.
Yes. What was the rule here? Same base?
Same base.
Right? So what are you going to say? X is equal to x squared minus 2. Do we know how to solve this? Yes, well, how do we solve this? X minus x squared plus 2 is equal to 0. Multiply everything by negative. So this is going to be positive x squared, negative x minus 2 equal to 0. Can you factor this? Good? Right? So what's the answer to this? X is equal to negative 1 and x is equal to positive 2. So 2 answers. X equal to negative 1 comma positive 2. $34. 34, we have 2 times pi to the power x equal to 32. Now we know 32 can be written as 2 to the power 5. You guys need to be familiar with the power rules, powers, how to, the basic ones, okay? So, but we have a 2 here. So now we need to, before we use the rule, we have to get rid of this 2, right? So how will you get rid of the 2? Divide both side by 5, so this is going to be 5 to the power x is equal to 16. Now it's easy, this is 2 to the power 4, x is equal to 4. Okay? So some are little abstract, but you guys can do it. I mean, not abstract, little challenging, I would say. 4 to the
How's that 4?
negative 3t, let me finish this first, is equal to 0.10. What's the question?
How is x equal to 4? Can you explain that?
Sorry. Yeah, so this is 2 to the power 4, 16. So x is, excuse me. Oh, this is 2, right? Sorry. So we have 5. Let me write this as 50. 50, okay, I'm going to change this to be 50, okay, sorry about that. So this is going to be 25, so 5 squared, so this is x is equal to 2 here. Now I'm going to do the other one with the bases are not the same. We are going to use a different rule when the bases are not the same, okay? This rule is, we still have to do those problems, but I need to include another rule for that, okay? So right now, convert to bases, so this number is this, okay? So now, so we have to do the other rule, okay? So right now, we are going to just follow that, and so now I am going to go into logarithmic functions, okay? So right now, (5.2) logarithmic functions. This is all intermediate algebra. Logarithmic functions, and their graphs. Okay guys, so logarithmic function is f of x. This is the definition in the book, log base a to x. This is called a logarithmic function. When this is the logarithmic function, if and only if this is the case, what this means is this. What this means is x to x is equal a to the power y. Now this value is the y, we know this is y. So if we have y is equal to something, we can convert that into that, okay? This means this is a rule, this is what logarithmic means. That's all, you have seen this before. Whenever we have a logarithmic function, we are going to graph that like that, okay? So now we are going to learn how to graph logarithmic functions. Okay, so example, let's do a basic one, f of x graph. So these are all graphs. Graph f of x is equal to log base 2 to x. Now logarithmic function also we had to know we have to write this restriction, x greater than 0. Logarithmic functions are only, the domain is x supposed to be greater than 0 and a is greater than 0. This base supposed to be greater than 0 and also a cannot be equal to 1. We are going to use these three conditions. Okay? So the domain of logarithmic function is only the x value is greater than 0. Okay. So let's do this. Okay guys, so when we have this, so what you need to do is you are asked to graph this without using the calculator or graphing calculator, So what you need to do is first thing we write y is equal to log base 2 to x. Now the rule says to convert this, right? Whenever we have, I'm going to convert this. Convert this into, well, how will you convert this?
X equals 2
This means x equal to
2 to the y.
2 to the power y. So whenever this means if this is the case, this is true. If this is the case, this is true. That's what it means. So we know this. So if we can graph, are we familiar with something like this, class? Are we familiar with something like this? Yes? So what is this? What kind of graph is this?
That is the increasing graph.
Yes, if we have this, if we can write this y is equal to the power x, this is something like this, right? We just did this. We covered this last class meeting. You guys did the homework, and I still covered this today, right? So this is called what? What is it called?
Exponential graph.
What kind of graph is this?
Exponential.
Exponential. This is an exponential, right? Graph. This is a basic exponential graph. Okay. So now, can I convert the x to y? Did we learn anything to convert the x to y and y to x? What did we learn? How we convert x to y and y to x. Can we do that? Have we done that before? Convert x to y and y to x?
Yeah.
Yes. In what functions?
Inverse.
What functions? Inverse functions. Very good. So whenever we do inverse functions, we convert x to y and y to x. So all I have to do is rewrite. I'm going to manipulate this now. What I'm going to say, find the inverse. So I'm looking for inverse of the log. This is a log function, okay? This is the log function. I'm going to find the inverse of the log. Are you following me? So what's the inverse of the log going to be? Y is equal to, substitute x by y, that's how we find the inverse, right?
Yep.
Substitute x by y, y by x. This is the inverse of the log function, okay? So now all I have to do is, I'm going to graph the inverse of the log function. So we know the points of this, right? What are the points of this? And we know how to graph this. What are the points? This is x, this is y. I know this is negative 2 and 1/2, negative 1 and, sorry, negative 2 and 1/4, right? Negative 1 and 1/2, 0 and 1, 1 and 2, 2 and 4, so we know this, but this is the inverse function. So inverse function is this, 1 and 2 here, 2 and 4. So we are very good with graphing the inverse. This is the inverse. This is the inverse of log base. Inverse, remember this is the inverse, okay? Inverse of what? F of x is equal to log base 2 to x. That's the inverse, okay? So if you know the inverse points, can we get the inverse of this? Inverse of this is this, right? The inverse, if you know this, inverse of this is going to be this. The inverse of each other, right? So how will you get the inverse of this? Take these points and switch. So what's the point here? What's the point here? 2 and 4. 2 and 4 going to be what? 4 and 2. 4 and 2. 4 and 2 here. 4 and 2. 2 and 4. 4 is 4 and 2. What's the point here? What is it?
1 and 2.
1 and 2 going to be what? 2 and 1. This is 2 and 1, guys. Right? So that's 2 and 1. What's the point here?
0, 1.
0, 1. And so this is 1, 0. Take the inverse. Take the inverse, right? And what's the point here? 1/2, right? X is 1/2. What's the y value? If I put 1/2 to x here, what's the y value? 1/4, right? Y is equal to 2 to the 1/2. Two to the 1/2. So the other way you can do is, guys, we discussed this, right? What is this?
The y is x line.
Y is equal to x line. What do we know with the we don't have to take all the points. What we need to do is you can pick the points in between these, and when you graph this, taking points in between these, the points y values are going to be bigger and bigger and bigger, okay? But it's not going to touch the y-axis here. So what do we know about this graph and this graph?
They're near x.
Symmetric with respect to
The y was x.
y is equal x line. Remember, I asked you to graph both function and its inverse. Then you need to write on the test, only few of you guys did the y is equal to x line and show the symmetry. You need to show the symmetry when I ask to graph both functions and its inverse. They are always symmetric with respect to what? Y is equal to x line. So now we are going to symmetry. So it's going to go like this. You see the log function now? This is the this is the inverse of f of x log x equal to 2. This is what? F of x is equal to log base 2x. See, this and this are inverse of each other. So the exponential function is the inverse of the what? Inverse of the log function. Are you following this? So now can you graph any logarithmic function? If you know to graph the exponential function, that is the inverse of the logarithmic function, you also know to graph the logarithmic function. All you have to do is graph the exponential, pick the points of the exponential one, which is the inverse of the log one, and switch the point, just like we did this here. Are we following? Okay, so for an example, if I ask you to graph f of x is equal to log base 4 to the x. Can you do this?
Yes.
What do you need to graph first? What do you need to come up with? You write this as x equal to 4 to the power x, 4 to the power y, and then take the log inverse of this. So inverse of is y is equal to 4 to the x. And now graph the inverse. So the inverse is going to be this, right? Right? And this is the inverse. So we know to get the log. So the log is going to be this. I'm just doing this. You guys know you can't do this on the test. You need to give me exact points, at least 5 points. Okay?
Yes.
Where the graph is going through. Okay, so this is what it is. So if I have log base 1/3 to the x, so this is going to be what? 4 is 1/3 here, correct? So what's the exponential one that you're going to do? Can we do this one? X has to be, A has to be greater than 0. So because we can't say log base, because according to our rule, A is greater than 0. So only we can get A is greater than 0 value. Now we are going to say log base, another example, log base e to x. Can we do this? This is called natural logarithmic function, you guys know that. This is called natural log. This is called ln. Okay. So you guys know this need to be written as what?
X equals e to the power y.
This is the log one. This log one can be written like this. But if you take the inverse, right? What's the inverse going to be like? Inverse is y is equal to e to the power x. That's the inverse. So you graph y is equal to e to the power x. You already know how to graph that. Oh my gosh, sorry. You already know how to graph that. And then all you have to do is what? All you have to do is, oh gosh, I forgot about this. Sorry about that. All you have to do is graph this, right? And you know, we just showed it you guys how to graph this, right? You have those 3 points, right? Inverse take the, change the switch x to y, y to x, right? And then the log one is going to be like this. Are you good, guys?
Yes.
Are we good? Okay. So we know how to graph this. Now we know how to graph e to the log 1. Now whenever we have this is also be written as, this is also be given as f of x is equal to ln x. Ln x. F of ln means log base e. Ln means log base e. Okay? So whenever you have f of x ln e means ln x means log base e. So if it's given like this, that means this. You guys have seen this, right? So note this, okay? This means this. So this means this. These are the same. Same. Also know that log base x, just log base x, f of x. So another example, this is another note. F of x equal log base x. You see a base here? Huh? You don't see a base, right? When you don't see a base, that means base 10. Like our number system is base 10, but we don't say base 10. But if it's a number system with base 2 or base 4, we write base 2, base 4. There are different number systems with different bases. Okay? You can create number system with different bases, but we have to say that the base when you talk about different number systems. But with the base 10, we don't write base 10. The same thing here. This is base 10. Okay? So whenever we see this, we graph the function to the base 10. You guys have seen this before, right? You have done work with this before. This is intermediate algebra. We have to, remember I said at the beginning, some of the topics we cover fast. I spend a lot of time with you guys to cover the new topics with you. Okay? So, everybody okay with this? No question? Okay, so now you know how to graph. Now I'm going to give you I had to run to my car to get something. Now I'm going to give you some logarithmic equation, some logarithmic rules. Logarithmic rules. Okay. So logarithmic rules are in page 392, page 392, 396, properties of natural logarithmic, and then 401 and 402. Okay? So what I want you to do is write these rules. First I'm going to go through these rules. You guys need to be familiar with these rules. So you guys, what is it? Page 394. Page 394. All these boxes. Page 396. So focus on these rules. Once we know the rules, we are good. We know how to apply all that, right? 396, and I'm not going to do this one, page 401. I might not do problems with this, but let's work with this also. Change of base formula rules. And basically what you need to know, these are the more important rules, page 402. So to get familiar with, I want you to write all these rules, right? Then I'll do few problems. I want you to write all these rules and I'll do few problems. Can somebody come to the board and write these rules for me? I'm going to run to the car and bring your review sheet. I left it in the car. Your homework sheet. Who like to volunteer to come to the board and write this for me?
Do you have a,
Huh?
I'll write it, do you have a, I forgot my book in the car.
Oh, I have the book here.
Oh.
Oh, thank you, Shine, thank you. So you can actually erase this board. Oh, it's so dirty.
These ones, but
Yeah, I did write. So write all the rules in here, and then when you come here, you guys have solved equations with logarithmic equations. This is very simple once you know the rule. You guys have done this before, right? Solving logarithmic equations, right? So I'm just going to, so you know what to do, right?
I'm kind of done. On page 384 though, which one's?
These box rules, the rules in the box, this one.
Okay.
Okay, so you're doing that. Let me show you.
So it's 392.
Yeah. So you're doing that. And can somebody else also help, please? You can help? Okay. So you have a book. So you can do these 2 pages and she can do these 2 pages. So you know what I'm talking about, right? Just go to the page and see the box one. Okay. So here, what, 401. 401, whatever the box. 402 are these, right? No, 402 I didn't write, okay. 401 is this, right? 401, 402. 402 is this, yes, boxes, okay? So, I'll be right back. Sorry about that, guys.
Yeah, there's one here.
She did, it's over there.
So everybody wrote these rules. Okay, some of these rules are very familiar to you. Pass it to the back, please. So what you're going to do for homework, this is 2 assignments. All the answers are given to you. And this is due the day of the final, so you have lots of time.
We need another one.
Huh?
We need another one. Our final's Thursday, right?
Huh? Yes. So, so what you're going to do is for now, just do the problems you can do. Okay, don't worry about the problems. There's some word problems here that you can do. We're going to talk about the word problems next class meeting. Some of the problems you can do is intermediate algebra word problems. Okay, so we will review it. So this is all review. And if I have time, I'll do only the circle next class meeting. Very simple. I'll take only like 10 minutes to do the circle problems, right? But do as much as you can. And so let me do some problems using these rules, okay? And if you have questions, okay. Oh, so I'm going to erase this. Okay, good. Thank you guys for those who Shaina and Cheryl. Thank you. Okay, so beautiful. So let me see. Okay, so I'm just going to do some problems. I'm just going to do let's say number 9, right? I'm just going to do a problem from this number 9. Number 9, because I don't have much time. Number 9 is from the review sheet, is 6 log base 7 x squared minus 1 minus 5 log base 7 x minus 1. So this is an expression, this is not an equation. This is an expression with more than one term. What does it say on the top? Use properties of logarithmic and write as what? Single term, one term. So this is more than one term. We are going to use properties of logarithmic. So this is properties of logarithmic. When you have multiplication of two things, you write as addition. Division of two things, you write as subtraction exponent you write like this, right? ln is the same thing, ln means log base e. Okay? It's the same thing. So, it's the same rule for, so now, this means there's subtraction here. So we need to get rid of the subtraction, it's the same base. Make sure it's the same base. Okay? So what do you write here? Log base 4, these are the two things, this is and this, the x, right? So we need to write subtraction, we need to write as what? We need to write like this. See, subtraction means what? Division, right? The rule, it goes the other way, the rule. When you have subtraction, we need to write as single, you write as division. Now can you simplify this? Can you simplify this?
Yeah.
Where do I have here? So we forgot something. How about this 6? How about this 6? First we need to put this 6. So write this 6 as log base 4. This is the number. This goes as power. Okay? Let's call the power rule. Where's the power rule? Here number, here n log base a to u. This n goes down here. You guys see that? If you have n log base a to x to the x means, if you have this as x means log a base x to the power n. It's the same rule. This is called the power rule, power property. So first get, I didn't see this 6 here. First get rid of this. Now is this. Okay? This problem so that's all we can do to this, right?
What about the 5?
Huh?
Yeah, you
What about
forgot 5.
Oh, I forgot about the 5. Excuse me, sorry, I didn't see the 5. So this is minus log base 4 to x minus 1 to the power 5, right? First use the base.
Where is log 7?
Huh?
And the problem is log base.
Oh, its problem is 7. Oh, sorry. I don't guess it. So it's 7, yeah. Log base 7. Okay. So now we can simplify this. This I can rewrite this as log base 7 x squared minus 1 times x minus 1 to the power 5. Can I do that? Can I do that? I can do that, right? 1 and 5 is 6, power 6. Right? Over what? Sorry? You can leave the answer like this without simplifying, that's fine. So I'm trying to simplify this. This means x minus 1 times x plus, this means x minus 1, 4 of these, right? 5 of these, so you can cancel with 1 x minus 1, so you get x plus 1 here, okay? So you can cancel this with, you just don't have to simplify all the way if this is x minus 1 and x plus 1 times x minus 1, x squared minus 1 here to the power 5 over x minus 1 times x minus 1 to the power 4. So this to this get cancelled, I write the remaining. Okay? You don't have to simplify all the way, just do as much as you can. Okay guys, so I just want to do so now this is when you have to reduce it to one term. Now if you do the other way, how about problem number oh my gosh, okay. Let me do number 11 too for you. The other way is not given to you here, number 11. There's 3 terms. So ln x over x minus 1 plus ln x plus 1 over x minus ln x squared minus 1, like this, right? So we can work with ln, this means log base. So first do these 2, okay? So if you do these 2, what do you write here? We have addition, correct? If you have addition, you are going to write 1 ln x over x minus 1 times x plus 1 over x minus ln x squared minus 1. So now you can, if you can simplify this, simplify first.
Yeah.
So this to this get cancelled. So this become ln x plus 1 over x minus 1. Subtract. So you do 2 terms at a time. Don't do everything together. Okay? You can do everything together also, but it's better to be careful. Okay? So now what do you need to use? You use what rule now? Division rule. So ln x plus 1 over x minus 1, this whole thing, divide this by this thing, x squared minus 1. So when you have a fraction, write like a division sign. So you can simplify. This whole thing you can simplify. You guys see that? So I write like that so that it's easy for you to simplify. So now you simplify, so this is going to be ln x plus 1 over x minus 1, and division into multiplication, 1 over x squared minus 1 can be written as x minus 1 x plus 1. Agree? So now simplify this, what do you get? This to this get cancelled. So it's ln 1 over x minus 1 whole thing squared. Okay? Okay guys, now, oops.